Welcome back, everybody. We are in concept development page 4.2, which is hang time. And hang time is how long you're in the air when you jump straight up. So sometimes when you watch an athlete, Michael Jordan or someone that just is amazing, they just seem like they just hang in the air and that they can go so far up. What you're going to see later is the ability to go straight up and the ability to run and go straight out are completely separated. So when a person takes a running jump and gets as high as they can, or they can just flat-footed jump straight up and see how high that they can jump, that they're jumping straight up into the air and then back down, the time that they're in the air is called hang time. And you can solve it by using the normal formulas that we had of distance and acceleration, because gravity is the same everywhere, so we're going to use g for acceleration. So they've given you a couple of these formulas. The speed of free fall, okay, so this is your velocity equals v equals at. This is how I did it, vat, okay. And remember, gravity is a specific case of acceleration, so this is v equals gt, so speed of free fall, acceleration times time. So it's 10 times t. That's your speed. Your average speed, if you remember doing averages with me, is initial speed, normally 0, or final speed. Sometimes it's 0 if you're jumping straight up and your final speed is 0. But one of those divided by 2, that's your average speed. And your distance is your average speed times its time. So rate times time. Here's your rate is your average rate. All right, so they're going to give you some easy questions here at the beginning. It says, if you step off of a table and it takes 1/2 of a second to reach the floor, what will be the speed when you hit the floor? Okay, so we want a speed, so this is 1/2, our velocity equals gt, okay, 10 meters a second is g, all right, so if velocity is 10, and then it was 1/2 of a second, okay, so you'll end up with 5 meters per second. You're going 5 meters per second when you hit the ground at a 1/2 second. What will be your average speed of the fall? Now, if you remember average, we're going to have to take, you were 0 to start with, you're at 5 meters per second when you hit the ground. Your average is going to have to add those together. So you're going to have 0 plus 5 divided by the number of numbers, which in this case is 2. So 0 plus 5 divided by 2, 0 plus 5 meters per second divided by 2 is going to equal 2.5 meters per second. That's your average speed. What will the distance be? All right, now distance, we're just going to use average speed times time. We've already calculated the speed. We've already had the g up here. If you remember the distance that had all of this, we've done 3 problems and we're taking stuff from each of the 3 problems. You could have done VOT plus 1/2 GT squared. It would have worked. It would work fine. But we're simply breaking it up, and so you have 3 easier problems rather than one longish one. So your distance, which is d, is going to be your average speed. Okay, that's what this is. This was your average speed. V sub average times t, which is, we saw it as 2.5 meters per second times 0.5 seconds. That's how long it took. So your distance, d equals, will be 1.25 meters. So a meter is about 3 feet. It's about the same as a yard. So it's like a yard and a quarter, or almost 4 feet. So you can jump off of an almost 48 inches would be 4 feet, 40 inches. That would be like jumping off my lab table. You might break your leg, but probably wouldn't. So how high is the surface of the table above the floor? Well, that's just what you were asked. It's 1.25 meters. Okay. Now we're not going to do the rest because this is what you're going to do in class today. We're going to jump and see how high you can be. Problem is all of our ceilings are so low. We'll see. We might have to go outside and jump up the building or something like that. But so, thank you.